So in this video, we're going to talk about possible energies of emitted photons and dark lines, and i.e., what do we mean by dark lines? The absorbed photons, photon energies, okay? And so we're given a graph here, and this is our K plus U graph. Okay, well, that's nice to know. Yeah, and we have the a particle quantum system has, electronic levels. These are K plus U, they're quantized, okay? And maybe we have a bottle at room temperature, okay? Okay, and all the systems are in the ground state, okay, and so we run a beam of electrons through the bottle, and we set the kinetic energies of the electrons to be around 10 eV, okay, to be around 10 eV, okay. Now my question is, what are the energies of the emitted photons, okay? What are the energies of the emitted photon? We're given the K plus U graph here, okay. So the first thing I like to do is I'm going to take my ground state. I'm going to take my highest electron energy level and subtract that from the ground state. I'm going to show you why. So we know this is our ground state. So this is E naught. We know this is E1. We know this is E2. And we know this is E3. Okay. So what I'm going to do is I'm going to subtract always the highest number from the lowest number to show me where I'm at. And so if I look at this, I'm going to take negative 16 minus 15 EV. Okay. And that gives me plus 9 EV. Because remember, anytime we want to find the, the emission, anytime we want to find the emission, it's always the highest, energy level minus the lowest energy level. So in this case, it would be E3 minus E naught, and we say that is just E3, which is negative 6 EV minus 15 EV, and so that's why we get 9. Okay, so I just wanted to point it out. Now here's the reason why I do this, because this number is significant. If this number falls below the beam that I set my electrons, the kinetic energy of the electron beam, then I know that all these emissions are actually possible. All these emissions are possible because it's less than the actual number that we set our EV to become to be. I'm going to show you the reason why I do that. So since we know that all these emissions are possible, since 9 falls way below, falls 1 EV lower than 10, we know that all our emissions are possible. And so how do we do emissions? It's always, I always start from the top and just go down. So we know we could have emissions from the top, and we could have it go straight down. Okay. We could also have emissions from the top to go straight to the second one. Okay. We could also have emissions from the top to go straight down to the first one right there. Now I'm moving down now. So I could also have emissions from here going all the way to the ground state. I also have emissions from here going all the way to there. Now I'm finished using up this second line, and the last one left is I could have emissions from here to here. Okay, so be careful. Notice how I did it. Always have emissions going all the way from the ground state to there, next line from there to there, next line from there to there, and then the last line is just 1. Okay, and so if I look at this in total, I have 1, 2, 3, 4, 5, 6. So I have 6 possible emissions. Okay, and so the only thing we're gonna do is just subtract those numbers. So if I take negative 6 EV minus 15 EV, I get plus 9 EV. So that's 1. If I take negative 6 EV and I subtract that from negative 11 EV, so negative 6 minus negative 11, that will give me a plus 5 EV. Okay, well, that's nice to know. If I take negative 6 EV and minus that from negative 8 EV, negative 6 plus plus 8, that will give me a plus 2 EV. Okay, so that's nice to know. If I take negative 8 EV and minus that from negative 15 EV, I'll get what? Plus 7 EV. So that's plus 7 EV. If I take negative 11 EV and minus that from, if I take negative 8 EV and minus that from negative 11 EV, well, negative 8 plus 11, yeah, so negative 8 plus 11, that will give us a plus 3 EV. And then the last one, if I take negative 11 minus minus negative 15 eV, I get plus 4 eV. And we get 1, 2, 3, 4, 5, 6. So those would be the electrons, the energies of the emitted photons. Okay. Now I just want to be clear. I just want to be clear. How am I getting these numbers to be positive? Okay. Remember, anytime we're doing emissions, okay, from the tail to the tip, from the highest to the bottom, okay, you take. So say for example, I want to do E1 to E2. What's the emission? I'd simply take E1 and subtract that from E naught, not E2, I'm sorry about that, E naught. Okay, and you could see E1 is negative. I have a negative sign here, and then I have a negative EV. So the negative times the negative becomes positive. And so all I'm doing is essentially I'll always get a positive number. Okay, so hopefully we're clear on this one. So now let me ask you a question next. What if we reduce the kinetic energy of the beam to be 8 EV? Okay. Now, what are the energies of the emitted photons? Well, again, now it's reduced to 8 EV. And so if I go back up to my graph and I do the emission from the highest to the lowest, E naught minus E3 minus E naught in this case, the highest to the ground state, well, we get a plus 9 EV again. This is interesting. So, in fact, the beam that we reduced it to, you can see that this is actually higher. So in fact, what this tells us is that we got to cut off this ground state here. We got not the ground state. We got to cut off the highest energy levels. Okay, and this is why I always tell you, okay, well, do the ground state, the highest state minus the ground state first. Okay, because in the first one, you could see that we got 10 and 9 fell between 10. Okay, but now that we have 8, 9 is actually higher, so it's not in the range. Okay, 9 is actually higher. And so what that tells us is that for the second problem, this has to go away. In order for us to get the range between that 8 EV mark, 9 is just too high. 9 is just too high. So in the first case, 10, 9 fell in between it, and so we'll get all the possible energies, okay? Because 9 fell between this 10 here, it's lower than it. But since now 9 is actually higher than our 8 EV, we'll actually not get all those emitted photons. And so what does that mean? We have to cut off the highest energy level. We have to cut off the highest energy level. Okay, that's what that means, because we're not allowed to go, we're only allowed to go up to 8. Okay, when we did the highest minus lowest, we get 9 EV, and we'll not see all those emitted photons. So what does that mean? This now has to be obliterated. And so if we look at this, we're only doing the absorptions now from E2 all the way to E naught. And so if I look at this, remember, we're not doing this anymore. So if I look at this, we could have from the second one from 8 EV, we could have from negative 8 to the ground state. We could have from negative 8 to negative 11. And then we could also have here. Okay. So notice, okay, so let me separate these a little bit so you can see. So this is for the second problem, because we're not allowed to go up to 9 EV because we're dealing with 8 EV. The beam of electrons is set to 8. And we have 9, so this top one here will not function. And so if I'm looking at this, well, what are my energy levels? Well, negative 8 minus 15, yeah, so negative 8 plus 15, now that will give me a plus 7 EV. Okay, that's nice to know. We have negative 8 minus 11, okay, so that will give us a plus 3 EV. That'll give us a plus 3 EV. Okay, and then we have negative 11 minus 15, which is negative 11 plus 15, and that will give us a plus 4 EV. And these will be the correct answers. And so again, if you follow that procedure, you can never be wrong. Okay, now the last question might ask, okay, well, we turn off the beam of electrons, okay, and the sample is cooled back down to room temperature. So all of the systems are again in the ground state, okay? Well, that's nice to know. Okay, so we shine a beam of light with a wide range of energies 0.1 to 11 eV to the bottom, okay? Okay, so my question is, what photon energies in beam are somewhat depleted, okay? What are the dark spectral lines? In other words, what are photon energies that are absorbed, okay? Now, when we talk about absorption, we're given a range here. So we got to make sure whatever electron energy level we get, it should be between this range. Now, the important thing to point out with absorption is that it only happens from the ground state. Only happens from the ground state. Let me repeat that again. Only happens from the ground state. And so if I'm looking at this, well, if I start at the ground state, I could get absorptions from the ground state to the highest energy level. So that's 1. I'll get absorptions from the ground state to the second highest one. So that's 2. I can get and I could also get absorptions from the ground state to the kind of third highest one. Okay. And those would be the only absorption that we get. It only happens from the ground state. And so I will actually see 3. And so you can imagine if I take -6, if I take -6 minus 15, okay, that gives me a plus 9 eV. Okay, that'll give me a plus 9 eV. Okay. If I take -8 minus -15, okay, that is a plus 7. So I'll get a plus 7 eV. Okay. And the last one, if I take -15 and I minus that from -15, okay, that is -11 plus 15, so that will give me a plus 4 eV. Okay, and those will be the photons that are absorbed. So hopefully this video makes a lot of sense to you. Now, I want to point out something here that in case you don't get confused with the subtracting, okay? Anytime you're doing emissions and absorptions, just always remember to subtract subtract the bigger number from the smaller number, okay? So on a number line, actually -6 is bigger than -15, okay? So always remember to subtract the bigger number from the smaller number. And so that way you'll never go wrong. So in this case, -6 is bigger. So therefore I take -6 and I minus that from -15. So that will give me -6 plus 15. And there, in other words, I get 9 eV. And that happens for absorptions and emissions, okay? So again, you could see that if I wanted to find the emission spectrum from -8 to -2, well, no, it's E3 minus E2. But again, if you find it difficult to remember that, just know that's always the biggest number minus your small number. So this would be -6, which is bigger than -8 minus -8. And so that will give us -6 plus 8. In other words, that will give us 2 eV. So numbers will actually always be positive when we talk about emissions and absorption. So if you somehow did the math and you got a negative number, just switch it because you did something wrong.